there's a lot engineering design that went into this, even though that this is our systems engineering approach. The hydrogen computer system you see here will be miniaturized down to several IC chips, which will allow us to give the economics to apply to a conventional car. Over here, there's very unique design features that had to be developed in order to develop the water fuel cell as a retrofit energy systems to conventional cars. Can you zoom in back in here? 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 The unit you see right here, this is referred to as a resonant cavity. Water is now fed into the resonant cavity through this water tank, and as such, we now expose the water to a very high intense pulse voltage field and restrict the amps, and therefore the electrical polarization process now allows us to release the hydrogen economically from water. And by attenuating the voltage field, the amplitude of the voltage field, we now can control the rate of the production of the hydrogen gas on demand. So this is what's referred to as a constant demand generator. We also now extend or allow the voltage amplitude to increase even to a higher level and allow the water atoms to go into an ionization state, which gives us the ability even to produce a higher energy yield by producing more hydrogen gas on demand. So the fuel now coming from the water through the electrical polarization process going into resonance meaning that we're actually tuning into the dielectric properties of water, and it allows us to reduce amps down, flow down to a minimum, and allow voltage to take over that disassociates the water molecule on demand. And those fuel gases are now coming through this electronic injector system as you see here. So basically we're now feeding the ionized air from the gas processor. We're now also taking the water fuel gases that are now coming from ordinary water. We are now mixing it with the non-combustible gases and the ambient air gases and regulating those control of the fluid mediums or for fluid mediums. And as a result, now we can tune in and allow this engine to run off of natural water. Control of the fluid mediums or for fluid mediums. This is demonstrated in our systems engineering approach on the technology that we can apply it to other applications, not only in the transportation area but also in industrial applications. So it's paramount that we would demonstrate and have the technology solved for design engineering, retrofitting to existing energy-consuming devices, whether it's being run in an internal combustion engine or a diesel engine or hook it to an industrial process. So all of these design interfacing technology is now being solved. We are in the latter stages of what we call the pre-engineering system, which will now allow us to miniaturize the technology once we're completed on the design applications and take it into mass production. I'll give you a classical example of this. We've also developed from this technology which we call the water fuel cell injector. And basically this injector now is a miniaturized water fuel cell or miniaturized resonant cavity. And this technology now allows us to simply replace, we can bypass this part of the systems approach and now simply replace the spark plug with the water fuel cell injector, and as a result now we can run the water up to the injector, which is now being processed and being exposed to a very high pulse voltage frequency, and as a result, as the water fuel is being going into the system, then the explosion takes place inside the cylinder, therefore it makes this an extremely fail-safe operable system. The cord that you see here is strictly hooks up to a very high intensity voltage pulse, and we restrict the amps to cause the electrical polarization process which in turn the voltage amplitude now takes it and goes in the ionization state to perform the hydrogen fracturing technology. And then in turn, the high pulse voltage frequency now allows the ignition of the gases. So therefore, we do this electronically. And so this technology has taken us down to the water fuel cell water fuel injector, as you see here today, which gives us a very economical way of simply converting and running a conventional car on natural water. So basically what we do is we feed ordinary natural water in here, non-processed natural water. We now feed the ambient air gases being ionized. It's being mixed with the water. And then we mix the non-combustible gases going in the system that regulates the control and so allows us now to release the thermal explosive energy from hydrogen and do it on a controlled means on gasoline and diesel fuel. Many people do not realize that when you run a car or truck on either gasoline or diesel fuel, you're actually running it on hydrogen. And all we're doing is using the hydrogen from water. And under the National Bureau of Standards figures shows that when you use water, the energy release is roughly 2.5 times more powerful than that of gasoline. So water is a very powerful fuel. And all you needed to do was solve the answers of, number one, producing the hydrogen economically, controlling it on demand, being able to adjust the burn rate of the hydrogen gas to co-equal the fossil fuels, and the third one was to be able to transport it without spark ignition. And we've solved all of these problems on the design engineering, and of course the water fuel injector, as I've shown you, now gives us the abilities to transport the water directly to the fuel injector, which is now going into the voltage zones, which now is performing the electrical polarization process that goes and triggers the hydrogen fracturing technology, but it's doing it inside the engine. So we all know that natural water is very stable, and therefore it becomes a very fail-safe operable system, as we pointed out earlier, and using ordinary natural water. You add nothing to the water. You don't process the water in any way. Now here's another feature to the system that everybody asks me about, is what happens to the water in the wintertime? Does it freeze up? Well, part of our technology was in the areas of development what we call a steam resonator. Now, since the unlike atoms take on opposite electrical charges, we simply use another part of our technology to restrict the analog voltage to take over, and therefore we agitate the water molecules, which in turn generates kinetic energy, which in turn heats the water. Now, this is phenomenal in the fact we consume very little electrical energy in order to heat the water. So there are very far-ranging advantages and features to the technology, ranging even in the areas that we now have a way of using voltage and by switching off AMFLO and dealing with the environmental control areas. We're developing the technology in the areas of desalination of salt water. Whenever you have a free and abundant energy source like water, it's only limited to the imagination to put it to work. This technology is very applicable to desalination of the salt water, handling of toxic waste chemicals by high pulse voltage frequency and restrict the amps. We now can separate the molecular structure of toxic chemicals and render them useless and safe. It also takes us to the technology of combining unlike atoms that heretofore was not possible under the natural state of covalent link-up. This led us to the development of the EPG electrical generator technology, where we're able to manufacture a magnetized gas that exists at room temperature and enhance the electromagnetic field without increasing mass. So our technology since the time of the era of embargo has been very far-reaching to give us a comprehensive energy source that we literally can use anywhere into the economies and move in a bilateral movement throughout the economies of the world to bring an energy source in. So it's imperative that we developed a technology that we can move very quickly, and of course water was the answer to it because water is a very free and abundant energy source. And so this technology has led us to the abilities of harnessing and using the water in this particular way, which we call the water fuel cell technology.
Could you give an indication of the amount of energy stored in a gallon of water compared to a barrel of oil, for instance?
Yes. As I pointed out earlier, when you separate the hydrogen and oxygen gases and go into the gas ignition process, its energy release is roughly 2.5 times that of gasoline. Now note the reference is not 2.5 times that of fingernail polish, It's 2.5 times that of gasoline. But in the hydrogen fracturing technology, we have developed a technology, as the Lord has shown me, that by igniting the hydrogen and oxygen gases and setting up a condition by which the water molecule is prevented to form, then we now can tap into a very higher energy yield. And as a result of this, the hydrogen fracturing technology shows that we can release energy up to beyond 2.5 million barrels of oil per gallon of water and do it safely. And as I had shown you earlier, we are now preparing this technology to be retrofitted directly to a jet commander, which we plan not only to fly around the world nonstop around the equator, but turn 90 degrees and go from the North and South Pole. So it's a tremendous amount of energy source. And what we've done is found a triggering process to allow us to release this tremendous amount of energy and do it safely. So it gives us the ability to not only sustain and maintain the economies of the world, but also give us the abilities to handle the environmental pollution problems at the same time. We can't keep putting CO2 in the air and expect that the energy level is going to be there even for our plants. And we all talk about the greenhouse effect, but very few people come up with a viable answer to it. And the water fuel cell technology gives us the ability to get us. Well, if you notice on my logo, you'll see Job 38, verse 22 and 23. And this is where the Lord is talking to Job, and he asks Job this question. He says, have you considered the treasures of snow, or have you considered the treasures of hell, which I have reserved against the time of trouble, against battle and war? Now, the interpretation of the scriptures are as follows. Is not snow the most beautiful part about water? That no one snowflake looks exactly the same as that of another? The treasures of snow is the characteristic and knowledge of water. The Lord knew that, in fact, that we would have and reach a very critical point in our history, that since we went on dependency of fossil fuels, the flow of fossil fuels may be disrupted. And as a result, the Lord specified that this knowledge of water would come out at a time of great trouble. But he also specified that the knowledge would come out prior to two events.
As you see right now, this is our injection pump housing, which houses our injection pumps, lubricated by our diesel fuel.
I feel that it's going to take the people of the world to come together, and the leaders of each country to come together in one accord in order to allow this type of technology to go on and stabilize their economic basis in each respective country.
Inside our injection pump housing, we see our fuel rack, which will be connected to our injection pumps. Injection pumps will consist of our spring, our plungers with a helix cut groove that will be actuated or moved upward by the cam lobe and lifter actions. Our plunger is mated to the barrel, which contains the spill port and the bypass port.
So basically, all we're doing is taking the gasoline out of the tank, fill it up with water. We now replace the spark plug with the water fuel cell injector, and we now hook a small little miniaturized computer which controls and meter mixes the gases going into the engine to allow the engine to accelerate and deaccelerate. So the installation is a very small, lightweight, compact electronic control system.
Our bonnet is mounted on top of the barrel, which contains our reverse flow check valve and spring. The spring keeps the reverse flow check valve closed below 100 psi. Our bonnet is either internal or external with threads for the fuel line nuts. The reverse flow check valve keeps the line full of fuel. Our camshaft will be actuating our injection pumps and rotating at half engine speed. Here you see our throttle linkage connected to our fuel rack.
And take it into mass production areas. We can do this by simply turning the technology over to many fabricators and people who have certain skills in the machining areas or mass production areas that will allow this type of technology to be produced.
And also connected to the fuel rack is our governor linkage. In this system, depending on the manufacturer or the engine, our governor would either be mechanical, which contains flyweights, linkage, and springs, or it could be a combination of different designs such as your hydromechanical servo type, or it could be a pneumatic. Here you will see our hand primer pump, which removes air from the system and contains two one-way check valve. Normally it's mounted on the siphon brake disc, which prevents fuel from siphoning back to the tank. And on this style you can see the hand primer pump mounted to the transfer pump. This is our mount for the injection pump housing, which is also used to set or adjust our timing. Normally our transfer pump is mounted to the front in the gear style, which provides 35 psi of fuel to the housing, which is also maintained by the constant bleed valve, which opens to 25 to 32 psi. Right now you can see the camshaft actuating our injection pump in firing order. Our stroke begins when the plunger is at the bottom of the stroke. At the bottom of the stroke, fuel rushes in above the plunger. As the plunger moves up, our plunger covers the spill port, creating pressure, and pressure is relieved once the helix cut passes through the spill port. Here we have our fuel rack metering our fuel. Basically, it's rotating our plungers, which is changing the position of our helix, changing our effective stroke. Our effective stroke determines the amount of fuel being metered. So it could be either a long effective stroke or short effective stroke. So let's look at the internal of our injection pumps. Right now you see our barrel and plunger, and a blow up picture of our helix cut, that when we rotate our plunger, the helix becomes longer. So at the bottom of the stroke, again, fuel enters the spill port, filling above the plunger, and as the plunger moves up, we create pressure. Injection begins when the spill port and the bypass port is blocked or covered, unseating our reverse flow check valve at 100 psi, sending fuel to the lines and the nozzle, and then injection ends when the spill port is uncovered as the pressure is relieved.
This whole hydrogen stuff, isn't it extremely explosive in the car? Is there any danger involved? What's the safety aspect of it all?
No, we have actually solved the problem. There's no storage of hydrogen whatsoever. The water goes into the injector, which now allows it to go into a high pulse voltage zone, which performs the electrical polarization process. So the water is only converted into thermal explosive energy as it enters the injector. So the thermal explosive energy is now occurring inside the engine. So the electronic system is designed to regulate and control the explosion of the energy, which now co-equals that of gasoline. So it's a tremendously fail-safe operable system.
Okay, so it's safe, it's a small system.
Yes.
What about maintenance of the car engine itself? Do I need more maintenance? Is there a difference? Is there anything, do I have to modify anything on the maintenance schedule?
No, just keep the same maintenance as you have it. Since you're releasing thermal explosive energy into the engine and you're co-equaling the burn rate of gasoline, then there's very little maintenance. If there is any maintenance at all, we developed the technology years ago that we could really impregnate the cylinder walls of the engine with Teflon, and we can even impregnate treat the bearings and literally run an engine off of the Teflon and eliminate the oil. If that occurs, then you can use a product something like Slick 50 in the engine if you would need it. But the wear factor, since it's a very clean burning fuel, hydrogen is a very clean burning fuel, then the engine oil is not contaminated under the old method of running on gasoline or diesel fuel. So it's an extremely clean burning fuel. This type of technology has given us the abilities to equal or supersede the performance of acceleration and deacceleration on conventional cars that's running on gasoline or diesel fuel. So the hydrogen, being 2.5 times more powerful than gasoline, gives us a tremendous amount of performance over the prior state of the art. It runs very smoothly, and it has a very unusual sensation. Generally, when you're running a car on gasoline, you have this kind of a pause. But when you're running on hydrogen, the way we're doing it, it's a constant acceleration. So it's a extremely very fast responding fuel source that's coming from water.
So you're claiming that performance is equal or better as a normal gasoline car?
Oh yes, definitely. It'll even start up quicker. In the wintertime, you're dealing with a liquid gasoline or liquid diesel fuel, and you have problems in starting. In cold weather, you don't freeze gas atoms, and so by converting the water into instant energy, gives us the ability to start the engine very, very quickly. Here we have a device with a metal bellows, which now allows to control the amount of ambient air going into the engine of the car. And this automatically allows us to regulate the ambient air pressures going from sea level up into the mountain areas. So electronically, these cylinders you see here have sensors that automatically senses the amount of ambient air pressures, and they're automatically electronically adjusted to compensate it for difference of air pressure. So this allows us now to give us tremendous good performance going from sea level right on up into the high mountain regions.